Hello, Pirates. Today's topic is ecological succession. And what we're looking at is how we can predict what will happen in an ecosystem over time given different events in the ecosystem. Ecological succession is a predictable replacement of species over time. And for example, we can kind of think in our area in Florida that if they mowed down a forest, so if they had a disturbance event like deforestation, and say that after they took down the forest that we just let the land stay there and we didn't put it in a neighborhood and we didn't add anything to it, could you predict what would happen over the next decade, the next 50 years, the next 100 years, the next 1,000 years? That's what ecological succession is all about. It's about predicting what will happen to the community, the living things in that ecosystem over time when there is some kind of disturbance event or when life is getting started there first altogether. So when we look at ecological succession, what we're looking at is we're looking at the replacement of species in an area over time. And this replacement is predictable. All right, so the first type of succession is called primary succession. And this is when we are colonizing species on bare rock. Okay, so barren land, nothing has ever been there before. In this kind of situation, there is no soil present. So it's kind of like when an island first springs out of the ocean or after a volcanic eruption where we just have rock. So think like the conditions of very early Earth, the very first land, or where new land is forming today. So primary succession is going to be first. Okay, so primary succession would be what happens in an area first when it is originally just barren land or rock and no soil is present. So like we said, this is going to be situations where land is colonizing for the first time after something like a volcanic eruption, or just on regular old rocks. All right, secondary succession happens when there's already been a community or an ecosystem present. So this is the replacement of species into an area after some kind of disturbance and soil is already there. So some types of disturbance events that you can think about are maybe after something like a fire. If there's a fire in an area, afterwards the plants will grow back. So after a forest fire, after a flood, maybe after a tsunami hits an area, after a hurricane, or maybe it could be after something like we said, after they put in like an agriculture field. Now, a couple of other key terms here. A pioneer species is involved in ecological succession, and the pioneer species, these are the first species to show up. So the first things that are going to colonize that barren land. So they're the pioneers to that area. And this is going to be things like lichens, which are kind of like algae and moss that grow on the rocks and break it down. So lichens and mosses. So this is kind of like the very first things. And then the climax community is kind of like an end result community. So what you end up having at the end. And with a climax community, this is a mature, stable ecological community that remains for a long period of time, and it might stay there for a very long time. So think of like an old mature forest. Think maybe like the redwood forest in California. Think maybe an old oak forest. In the southern United States, or really anywhere. We have lots of oak forests throughout the United States. All right, so we're just going to kind of look at how this process happens real quick, and we're just going to illustrate primary succession and secondary succession. So here we have at the first one here we have primary succession. So this is when land is being colonized for the first time. And if you guys look at the time frame for primary succession, you guys can see that this can take from just a few years to hundreds of years. So it could even be thousands of years. And what we're starting off here is we're starting off with this barren rock. So here we have this barren rock Nothing is there. Nothing has ever lived there before. And the first thing that's going to move into that area are the pioneer species. All right, so we're going to have pioneer species show up first. And so what's going to happen, little things like mosses and lichens are going to start growing on the rock. And these little mosses and lichens, they're going to start to break down the rock over time. And as they break it down, they are going to slowly build up soil. So we're starting off here with no soil. And over time, we're going to start to build up a soil layer as the rock and the plant material that lives in the area is going to decompose and create that soil. So we're going to have a slow process of building the soil over time. All right, eventually, as soil does start to form in this area, little grass plants are going to start to colonize the area. So we're going to start to see little grass plants. Eventually, the grasses will give rise to little shrubs. So we're going to start to have like bigger plants in the area. Little grass plants, bigger shrubs. And these are going to be our intermediate species. So these species will be intermediate. That's an R. So we'll have intermediate species. We'll start to see some small trees. And maybe these small trees will eventually be replaced by trees that really like the sun. So things like pine trees. And over time, these trees are going to kind of start to bring shade into the area. And what is going to come next is plants that can grow up in the shade. So eventually, pine trees, for example, oftentimes they get shaded out by larger deciduous trees, oak trees. And so in the end, we'll end up with our climax community, our stable community. So here we have the climax community, and it will stay that way for, and just kind of replacing itself, maybe an oak forest, until maybe it has some kind of disturbance event. So we have that primary succession. Maybe what happens then is maybe there is a forest fire in the area. Then that is when we would see secondary succession. All right, so then we would have something happen like secondary succession. So if there's a forest fire, for example, say we have our original forest. So here I've got my pine trees. And this could happen at any stage in this process. So here we've got our pine trees. Happy little pine trees. They have their soil that they're growing in. And then we have a disturbance like a forest fire. So here comes a forest fire. It could be a hurricane. It could be a tsunami. And what's going to happen is this is going to cause the ecosystem to kind of like almost like reboot or restart. So a lot of the plants are going to die. Maybe not everything. The animals will migrate out, or also maybe they might not survive the forest fire. But overall, after the forest fire doesn't get rid of the soil. It actually might bring nutrients into it, or in the case of the tsunami, it might shift the soil. So the soil is still going to be present. The forest fire is going to help build that soil. And so what's going to happen is this community is going to be able to come back faster than when it originally colonized, because there's already soil and nutrients to build on. And so again, the first things into the area might just be those little plants and shrubs, little grasses, those early pioneers to the area. And eventually they're going to make way to those bigger, plants are going to come in to the area. They'll eventually make way for the shrubs and the small plants. We might start to see small trees much sooner. Again, there might already be a seed bank in the soil for some of these small trees. And over time, what's going to happen here is our community is just going to grow and thrive. So it's going to start with those shade-tolerant plants, or not shade-tolerant, plants that love the sun. Pine trees love the sun. And eventually, we're going to get back into the climax community. So what was there before will return to that ecosystem. It's just that this time it's going to happen much more quickly. All right, and you can look at that question at the bottom, and the question at the bottom asks why. It says, why does this happen more quickly the second time around compared to the first time around in this process of ecological succession? So I'll get some trees in the background there. All right, so it says, hypothesize why secondary succession happens much faster than primary succession. And overall, you guys can kind of think the thing that is different is you got it, it's the soil. It happens more quickly because the soil and nutrients, and a seed bank is already present. Key feature, if you were ever asked on a test, they'd be focused on, the soil. All right, so what you guys are gonna do is you guys have your notes, watch a couple videos. They show you guys some pictures of volcanoes and things in the Khan Academy video. But with this, on page 150, so you guys have those notes. Okay, on page 150, you just want to make a Venn diagram, and I'm actually going to make a bullseye target chart, just to make my life exciting. But what you want to do on page 150, and this is what you're going to submit, is you want to submit a comparison and contrasting of primary and secondary succession. So on the left, you're going to have primary succession. And then you're going to have secondary succession over here on the right. So here we have secondary succession. And then in the middle, you'll have things that are both. So this is just a different format of a Venn diagram. So you want to put the things that are unique to primary succession, see if you can come up with maybe 1, 2, 3, 4 things, and then also provide some examples, and then see if you can come up with, about 1, 2, 3, 4 things going on with secondary succession that are unique to that, and then what are some examples. And then in the center, you want to come up with what do they have in common. So what are the things that both secondary and primary succession have in common? So this is your Venn diagram, bullseye, or target chart style. Fill that out, submit that to me. Reach out if you have any questions. I hope you guys have a wonderful weekend.